she'll be talking about Greenland, meltdown in the north.
Good afternoon. So my name is Rennermalm. I'm an assistant professor in the Department of Geography. And I study hydroclimatology in the Arctic region, which includes studies of the Greenland ice sheet. To tell you a little bit about my background, I was born in Sweden. I went to Denmark to take my undergraduate and master's degree. I got my PhD from Princeton. And before coming here, I was at University of California in Los Angeles for a postdoc. Now, I'm sure many of you are aware of the dramatic changes that we are observing in the Arctic region today. Perhaps the most notable is the rapid decline of sea ice. But the reason why we should be concerned about the changes in the Arctic is not only what occurs today, but what is expected for tomorrow. This map of the world right here shows the projected temperature changes from the end of the last century to the end of this century. In this map, the regions that are expected to experience the most dramatic changes appear in purple. As you can see, these are the Arctic. This is in the Arctic region. So some of the science questions that I'm addressing is all related to the Arctic and some of the changes that are being expected up there. And I want to, with my research, understand the state and the dynamics of the hydroclimatology of the Arctic region. But not only that, also we need to understand how the changes in the Arctic are affecting the population beyond the Arctic. What are the global impacts? One way in which the Arctic region could have a significant impact on global environment is through rising sea levels from melting ice sheet, particularly the Greenland ice sheet. So let me demonstrate a little bit. This map right here shows Greenland in gray, surrounded by ocean in blue, and you see sea ice in white. What I want you to notice in this map are the red areas. These are the areas where satellites have detected surface melting. And in this particular map, it's melting during the month of September in 1980. Now compare this with the situation in closer to today, which is shown here from September of 2007. Now in this map, you can see how the red areas where the surface is melting of the Greenland ice sheet has expanded tremendously. So the big question is, how is this increased melting affecting the functioning of the ice sheet? To understand this, I'm employing two methods. First, I'm going out in the field and making measurements of how much meltwater is coming off the ice sheet. And I'm also combining this with developing models to understand more about the processes driving the ice sheet. So my field experiments are done in the southwest of Greenland. And the big map to the right shows, the black diamond shows where I'm making measurements of stream discharge in rivers that drains the ice sheet. And you can see on the smaller map where in Greenland I'm at. And also the drainage area of the part of Greenland that delivers meltwater to my field sites. Here are some pictures of me in the field. I'm taking discharge measurements, putting in sensors that observes stream parameters throughout the year. Despite the importance of the Greenland ice sheet in a future climate, these type of measurements are actually extremely rare. I'm aware of 4 other sites where similar observations are made. And none of these data are available to the public for free. So there's a huge lack of data when it comes to monitoring the Arctic and Greenland ice sheet. Now, while these observations tells us about how much water is coming out and what the variability looks like over the melting season, it doesn't give us much details about what's driving the meltwater and gives insights into the functioning of the ice sheet. So to do that, we need to use models. So I developed a model that is a spatially distributed model. Here we see a part of the Greenland ice sheet where our drainage basin is in a gray shade from black to white. And you can see the coastline of Greenland to the other side. And this one uses modern data inputs of meteorological forcing variables. But to see how much comes out of these ice sheet, you need to add a routing scheme. And this has typically only been done in a lumped fashion for ice sheet. So a novel extension of this approach is a distributed network of reservoirs where the water is transported and melting in different grid cells over this drainage area. And here you can see this drainage network across the ice sheet. The end product of this type of model is a time series of meltwater export driven by meteorological variables. So here you see a typical time series of surface melt coming off the ice sheet with this model over a melting season. In this particular case, it's 2008. So the great thing now that we can do by having the observation that shows the total water coming out of this site, and this model that shows how much of this water is driven by meteorological factors, we can also see what is not explained by meteorological drivers. There's been many observations of the formation of surface melt flakes on the surface of the Greenland ice sheet, and there are lots of questions what this means for the dynamics of the ice sheet. And by combining my measurements with my model, I'm able to look at, okay, what is it that we cannot explain with this type of model? And what I found is that you see this pulse-like behavior of meltwater not explained meteorological factors over a melting season. So some of my future work will look into what's causing that. So my Greenland work is actually, it's only a part of a larger work that addresses the Pan-Arctic hydroclimatology, and it relates to understanding the system of the Pan-Arctic. But I've also done a range of other studies that looks into the changing Arctic, that is monitoring and observing and quantifying trends that occurs in the Arctic climate system. For example, I use spatially distributed data sets of river discharge to examine trends in subsurface hydrology, and perhaps even driven by permafrost thawing, seeing how we have an increased flow of water coming out of the Arctic ecosystem. But I also looked into how different components of the Arctic climate systems is interacting with each other, such that, for example, the receding sea ice seems to have, in some parts of Greenland, have an impact on the surface. It could potentially have an impact on the melting of the Greenland ice sheet. And of course, taking the next step, which is examining the impacts of these changes on a global level. And for this purpose, I've been using global climate model of intermediate complexity to look at the impacts of changing river discharge on things like ocean circulation, which has a global reach, but also look how hydrology interacts with ecosystems in controlling greenhouse gas emissions to the atmosphere. The Arctic region contains a lot of the soil organic carbon of the globe, and there's a great concern what's going to happen to this in a future climate. So some of my studies looks into this as well. And all of these things are aspects that I'm bringing on for my future work, and continuing examining Greenland and its impact on the global sea levels by looking into some of the questions that my modeling and measurement study has opened up, but also getting to the fundamental question, namely how much of the melting of the Greenland ice sheet is contributing to rising sea levels. But I'm also interested to continue working on trying to understand, so what is this new Arctic landscape going to look like if the warming continues? And finally, of course, the human impacts. How is this new environment, how is this going to affect the people of the Arctic and the people elsewhere? Thank you.
Any questions?
Would that particular sampling site you chose
Yeah.
is a good representation
it would obviously be ideal to have multiple sampling sites across Greenland. It's because it's in the Arctic. It's very remote and hard to access. This turns out to be one of the sites that are one of the easiest to access. And I think as Greenland is going to become more important, there's going to be more efforts to have an expanded observational network across the Greenland continent. But it turns out that the southwest of Greenland is an area where we see a lot of increased melting. So I think at this point we want to study as wherever we can study. But yeah. Anything else? Thank you.
Thank you.